In this video, we are going to learn how to solve problems involving concavity and inflection points of a function. After going through this video, I guarantee you that you will be able to solve problems involving concavity and inflection points of a function easily and fast. So make sure you stay with me to the very end of this video. Okay, so let's go into the details of the video. But before we do that, let me illustrate some things that will help you in the long run. Now, when the graph of a function is concave up, this is concave up, the second derivative f double prime of x is said to be positive, which means that the first derivative f prime of x is increasing. Whereas when a graph is concave down, it means that the second derivative f double prime of x is negative, meaning that the first derivative is decreasing. Again, at inflation points, let's talk about inflation. At inflation points, f prime of x is said to be 0. Now, let's look at this trajectory. Let's say you have something like this. At this point of the function, where concavity changed is known as what? Inflection point. So inflection point is simply the point of a function in which concavity changed or changes. As you can see here, the graph was concave down. All of a sudden, at this point, the concavity changed and it started to go upwards. So at this point, where concavity changed, now the inflection point. Or the same thing. What of this graph? At this point, the concavity was up. At this point, the trajectory changed and it came down. So this is, at this point, it is also known as the inflection point. So it's important to put this into consideration or into cognizance so that you will be able to solve problems involving concavity and inflection point very well. So having taken note of these things I have illustrated, let's look at a typical example now. Just solve the question so that you understand it better. The question says, given f of x equals x raised to the power 4 minus 4x raised to the power 3, and we asked to find the inflection point concavity of this function. Now remember that at inflection point, f double prime of x equals 0. So that means let's find the first derivative. F prime of x will be, when you differentiate, you're going to have 4s cubed minus 12x squared. Then find the second derivative. So f double prime of x will give you 12x squared minus 24x. So if you factorize this, you're going to have 12x in bracket x minus 2. Okay, so that's what we're going to have. That means to simplify this further, we are going to have two answers for x. So it will be 12x equated to 0 equals 0 and x minus 2 equals 0. So at this juncture, you get the respective values of x. So for this side of the equation, you divide both sides by 12. So this will cancel out. So when 0 divide a number, you get 0. At this point, make the solid formula. This minus 2 because of the equality sign and change to what? Positive. So when the inflection point of x to be 0 and 2 respectively. So let's verify this principle and check if we get 0. Remember, at inflation point, f double prime of x is 0. So when you take 0 and plug it here respectively, you are going to get 0. 0 minus 2 will give you minus 2. 0 times 12 will give you 0. 0 times everything in the bracket to give you 0. So it's correct. What when you put 2 in this values of x, 2 minus 2 give you 0. 2 times 12 to 24 times 0 in the bracket to give you 0. So the values are correct. It validates this principle here. Okay, now that we have gotten the inflation point of the function, let's determine the concavity, whether it's concave up or concave down. I'm going to explain that using number line. So remember, we have the inflation point of x to be 0 and what 2. Okay, now let's take a number that is greater than 2. Any number. Okay, let's use 3. When you plug 3 here, and 3 here as well, and do the calculation, let's see whether we're going to get a number that is positive or negative. So when you put 3 here, 3 minus 2 give you 1. 1 times, when you put 3 times 12 here, you get 36. 36 times 1, you give it 36. So it goes 36, which is a positive number. Okay, now let's take a number that is less than 0. Okay, this time I will use minus 1. When you put minus 1 here, minus 1 minus 2 give minus 3. Okay, minus 1 times 12 give minus 2. Minus 12 times minus 3 will give you 36. It will still give you 36. That means the concavity of this function, you can see, that means this function was decreasing. All of a sudden it started to increase again. That means the function is said to be concave up. The concavity is up. Concave. That means the trajectory of this function, if you want to illustrate graphically, it will be something like this. This is the inflation point of here. It was decreasing. All of a sudden, it was increase. The scenario was like this. The situation was like this: 0, 2, and we're having negative 36 here and negative 36 here. It would have been concave down because the function will be increasing, and all of a sudden it start to decrease. So when we want to represent it graphically, it will be something of this nature. So let me draw the graph way. Okay, so it will be something like this, the inflation point of which it was increasing, and all of a sudden it starts decreasing. So now that you have gotten the actual concavity of the function, which is concave up, I'm not making use of this, so I'm just trying to explain something. So the graph is concave up. Now let's get the inflation point of y, because it might also represent the coordinates of x and y. So since we have gotten, let me have space. Now, since we have the inflation point of x to be 0 and 2, okay, to get that of y, all you have to do is this inflation point of x, you need to substitute the values here. So when you do it, when x equals 0, y, f of x something as y will be, so we're going to have 0 raised to the power 4 minus 4 bracket 0 raised to the power 3. So when you simplify the everything will give you what? 0. Okay, when x equals 2, y will be, okay, in bracket 2 4 minus 4 bracket 2 raised to, this is 2 raised to the power 3. So when you simplify this, and 2 raised to the power 4 give you 16. 2 raised to the power 3, 8 times 4, 32. 16 minus 32 equal minus. Okay, so we have the inflation point of x when is 0 and 2. That of y is 0 and minus 16. Okay, so to represent them properly as coordinates, we are going to have them to, this is how you represent it properly. When x is 0, y is 0, and when x is 2, y is negative 16. So this is how you present it in coordinates, the inflation points. So guys, I hope you learned something interesting. These are how you can find concavity and inflation point of the function easily. So with this, I'll come to the end of the class. If you're new to the channel, ensure you hit the subscribe button to subscribe to the channel for more videos. For more, also like, share, comment on this video to tell me how you feel regarding what you have learned from this class. If you seem to have any specific questions, feel free to give your question at the comment section below, and I will be sure to give you a response. That's it for this class, guys. Thanks for watching. See you in my subsequent video.